Good morning, class. Today we are working on lesson 11.8 out of your GoMath textbook. So if you have not already, please tear out pages 669 and 671. Sorry. All right, so today's lesson 11.8 is on the area of combined rectangles. The essential question is, how can you break apart a figure to find the area? So let me zoom on in. We did the break apart method earlier in this year when we were solving more difficult multiplication problems. So now we're going to use that same idea with finding the area of large grids or awkward shaped grids. Okay. So we're going to use the distributive property to break apart the array. Remember, the distributive property, you're just going to break apart to make more friendly numbers, and then we add them up to put them back together. So essentially what we're going to do is we're going to break apart this big array into two smaller arrays. We're going to find the area for those two smaller arrays, and then we're going to add those two areas back together to find the area of the total big array. I shall show you. Here we go. Anna's rug has side lengths of 4 feet and 9 feet. What is the area of Anna's rug? Use square tiles to model 4 times 9. Okay. So I've got 1, 2, 3, 4. Okay. And then I'm going to go across 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, I cut it close. So now I have 4 rows of 9. Okay. So 4 and 9, right? And we're going to pretend that we don't know what 4 times 9 is. Now, we all know what 4 times 9 is because we memorized our multiplication facts. But we're going to pretend that we don't, okay? Now, since 9 is the larger number, that's the one I'm going to break apart, okay? You can break apart what you want to break apart. But we're going to break the 9 apart. And so you might say, well, how are you going to break apart the 9? Okay, let me get a different color. I am going to draw a line to break this into two smaller arrays. Now, to make it even more clear, I'm going to shade my two separate arrays because I really want you to see the two separate rectangles. So this one will be yellow. Okay. Oh, that is bright on camera. And then the other one will be pink. So I'm breaking this large rectangle into two smaller rectangles. So instead of one big rectangle, I now have a smaller yellow one and a smaller pink one. So I need to find my new measurements to find the area of the yellow rectangle and the area of the pink rectangle, and then I will add them back together. Okay, so the side length 9 we broke into 1, 2, 3, 4, 5. So we want to label our new rectangles, and 1, 2, 3, 4. 5 plus 4. Well, 5 plus 4 equals 9, right? Yes, so that makes sense. I broke the side 9 into a 5 and a 4. And this side is still 1, 2, 3, 4, and 1, 2, 3, 4. Okay? So now I have new multiplication sentences to represent each of these. So rectangle 1, we'll say is our yellow one, is now a 4 by 5 rectangle. And I know 4 times 5 is 20. Okay? Okay. So this rectangle, yellow, is 20 square feet. Okay. Rectangle 2, the pink one, is a 4 by 4. And 4 times 4 is 16. So my pink rectangle's area is 16 square feet. All right, so we broke these apart to choose simple rectangles that were easier to solve, but we want to know the total area of our original rectangle. So we have to add these two areas together to get the total area of this whole rectangle. So I've got 20 square feet in my first rectangle. I have 16 square feet in my second rectangle, which means the total is 36 square feet for this entire large rectangle, the original rectangle. Check your answer by counting the number of square feet. So you could sit and count all these squares up that are inside to check your answer, and you would have 36 squares. But I can also, because we know our multiplication facts, I can go back and check, well, 4 times 9 equals 36, and that's what I got, 36 square feet. So the area of Anna's rug is 36 square feet. Okay, flip your page over. And this is what I meant by awkward shapes. The boot that we've talked about. See, when you turn it, it looks like a boot. Okay. Use the distributed property you found. Use the distributed property. You found that you could break apart a rectangle into smaller rectangles and add the area of each smaller rectangle to find the total area. How can you break apart this figure into rectangles to find its area? So there's different ways that you can break these apart. So they're going to show you one way or another way, okay? So basically you're going to cut off the part that's sticking out, either this way or this way. So instead of an L shape, you have two rectangles, because we know how to solve the area of a rectangle. So now we have two rectangles. We solve those, put them back together, and then we get the area of this L shape, okay? Now, it doesn't matter which way you do it, your answer will be the same. Okay, so the first time they cut this off, okay, and they created this square, okay, and this, that's not a very good tracing job, rectangle. All right, now let's label our new rectangles. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. So this rectangle is 3 rows of 7, and this one, 3 rows of 3, which is a perfect square, okay? So rectangle 1, we'll say is the one on top, is 3 rows of 7. 3 times 7 is 21. Are you beginning to see why I had you memorize all your multiplication facts? It makes this way easier. Rectangle 2, 3 rows of 3. 3 times 3 is 9, okay? But I want to know the total area of this entire L-shaped figure. So I need to add up this rectangle's area plus this rectangle's area, which would be 21 plus 9, which equals 30 square units. Now, let's show the other way and see if we get the same result. So over here, they made this rectangle and this rectangle. So we have two rectangles now instead of one. Let's label them. I've got 1, 2, 3, 4, 5, 6 rows of 3. And I have 1, 2, 3 rows of 4. There's my two rectangles. So in rectangle 1, I have 6 rows of 3, and I know that 6 times 3 is 18. Then on rectangle 2, I have 3 rows of 4, which I know is 12. Now, again, I want to know the total area for this entire figure, so I need to add these two areas back together. 18 plus 12, which totals in 30. Your answer will be the same no matter which way you decide to chop it into two pieces. So that means the area is 30 square units. Okay, come down here. Draw a line to break apart the figure into rectangles. Find the total area of the figure. Think, I can draw vertical or horizontal lines to break apart the figure to make rectangles. So you could do it this way, or you could do it this way. Okay, either way works. I'm just going to go straight up and down like that. So now I have 2 rows of 1, 2, 3, 4, and 1, 2, 3, 4 rows of 1, 2, 3, 3. So rectangle number 1 is 2 rows of 4. 2 times 4 is 8. Rectangle number 2 is 3 rows of, or sorry, it should be 4 rows of 3. I wrote that backwards, which I know is 12. And I want to add them back together to get the total. So 8 plus 12 would be 20 square units. And if I counted up all these square units, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, you can see that that's 20 whole. Okay? All right, grab your next page. Let's keep practicing. Okay, use the distributed property to find the area. Show your multiplication and addition equations. Okay, so they're wanting you to show both. Basically, just show all your work. So you might say, these are normal shaped rectangles. Why can't I just solve it? You could, but we are following directions and pretending that we don't know our big multiplication facts. We're going to follow the directions and we're going to chop it, okay? So this time I'm going to mix it up, but I'm going to go horizontally. Boom. And I always like to take my line through on both sides so it's easy to see where it's at. The top, I have 2 rows of 1, 2, 3, 4, 5, 6, 7. And the bottom, I have 2 rows of 7. Okay? So I'm going to have rectangle 1, which is 2 times 7, and that equals 14, right? Okay. Plus, I have rectangle 2, which is 2 times 7 equals 14. And then I'm going to add them together. 14 plus 14 equals, we have 10 and 10 plus 8, 28. So 28 square units is your total, and you can go back and count all of these to check it. Okay, let's go vertically on this one. I'll just chop it right here. So now I have 1, 2, 3, 4, 5 rows of 1, 2, 3, 4. And I have 5 rows of 1, 2, 3, 4, 5. Okay. So I have rectangle 1 is 5 times 4, which I know is 20. Okay, semicolon to separate. Rectangle 2 is 5 times 5, which I know is 25. Semicolon to separate. So now I want to take this total and add them together. So 20 plus 25 equals 45. So that means the total area is 45 square units. Okay, I want you to pause the video and I want you to do the same thing for 4 and 5. And then I want you to continue to find the area by breaking apart these two shapes on 6 and 7. So you're going to do 4, 5, 6, 7. Do not just solve without breaking it apart and using distributed property. We need to follow directions. So pause the video, come back when you have all 4 of those complete. Okay, if you have returned, then you have completed these 4. And I'm going to tell you right now that you may not have broken them apart in the same way that I'm going to break them apart. And that's totally fine. The only thing you need to do is make sure that your math is correct and that your final area is the same as my final area. So if you didn't do them the exact same way as I did, then that does not mean you have to fix it. It does not mean you did it wrong. Just check and make sure your math along the way is correct and that your final area is correct. So here we go. I am going to do a vertical line to chop this. And this has 3 rows of 4 and 3 rows of 4. So 3 times 4 for the first rectangle equals 12. And 3 times 4 for the second rectangle equals 12. We add those together. 12 plus 12 equals 24. So this is 24 square units. Okay, I'm going to see how many this is before I decide which way I want to chop it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's what I thought. I thought it might be 10. 10s are easy to solve, so I'm not going to chop a 10. I'm going to keep the 10, and I'm going to instead chop it this way. So now that I have 2 rows of 10 and 2 rows of 10. That's going to cut into my answer, but okay. So I have 2 times 10, which is 20. So that's this rectangle. And then I have 2 times 10, which is 20, and that's this rectangle. I'm going to add them together to get the total. And so the total area is 40 square units. Okay. Draw a line to break apart the figure into rectangles. Find the area of the figure. All right. Well, I could chop it this way, or I could chop it this way. So let's go up and down. I'll just follow this seam. So now I have a rectangle that is 4 rows of 3, and I have a rectangle that's 2 rows of 6. Okay, you see the 2 separate rectangles? Now rectangle 1, I have 4 times 3 is 12. Rectangle 2, 2 times 6 is also 12. So 12 and 12. You got to add them back together to find the total area, which is 24 square units. Here, go deeper. We're going to actually make 3 rectangles. And believe it or not, there is 2 different ways that you could do this. So I could draw a line here and here, and that would make 1, 2, 3 different rectangles. Or I could draw one long line across here, and that would make 1, 2, 3 rectangles. So let's do this way. Oops, my paper moved. And this way. So now I have 1, 2, 3, 4 rows of 3. And here I have 2 rows of 3. And here I have 4 rows of 3. Okay. So I have 1, 2, 3 rectangles. So rectangle 1 is 4 rows of 3, which totals 12. Rectangle 2 is 2 rows of 3, which totals 6. Rectangle 3 is 4 rows of 3, which totals 12. And now I need to add them all back up. So I've got 12 plus 6 plus 12. Okay, well I know 12 and 12 is 24, right? So what's 24 plus 6? 30. So I have 30 square units. Now, if you did not get the same total as me on any of these problems, I want you to pause the video and try to find out where you went wrong and see if you can correct it. You don't have to do it necessarily my way, but you can probably figure out a way to make your way work as long as you check it and your math is correct. All right, so once you've made corrections to this page, head on over to Think Central to complete your assignment for the day.